azulenes. Now we proceed to polycyclic compounds. Although polycyclic compounds are not new to you, for example, naphthalene, anthracene, phenanthrene, but we'll just revise them and brush them up all the information that we already know. Now, these are the few polycyclic aromatic hydrocarbon examples. Like the first compound on this category is a very well-known compound to everybody, that is naphthalene. Then it is quercene, pyrene, and so on and so forth. Anthracene is also another very important compound that has not been mentioned here. So, Friedel-Crafts alkylation reaction takes place between two molecules of benzyl chloride and it yields 9,10-dihydroanthracene. This compound, which is shown in a square bracket, oxidizes very easily and losing two atoms of hydrogen yields anthracene. The reaction is conveniently placed in the presence of AlCl3. Second up is the Diels-Alder reaction. Now, Diels-Alder reaction involves a diene and a dienophile. Diene here is butadiene and the dienophile is 1,4-naphthaquinone. Those two of the reactants are shown in the reaction. Now, the first step actually is the Diels-Alder reaction. So, electrons from dienophile attack the carbon C1 on the diene. I have also numbered the carbons of diene as well as the dienophile. The involving carbons of dienophile, only those I have numbered as in the blue box and of the diene in the yellow box. So the electrons from the dienophile, they attack the carbon C1 on the diene and this results in a single bond formation between C1 and C5. Now, electrons from the double bond between C1 and C2, they relocate themselves between C2 and C3. Further moving, the double bond between C3 and C4 is broken and the electrons form a single bond between C4 and C6 to form the product. Now all these processes, they take place in a single step. So this is actually the first step of the reaction is the Diels-Alder reaction. Moving ahead in the second step, now chromium trioxide and acetic acid in their presence 9,10-anthraquinone is obtained which changes into anthracene in the presence of zinc. The next method of synthesis is Fittig reaction and Fittig reaction is quite easy to understand. Wurtz-Fittig reaction is not a new reaction for you as is easily seen that the condensation of the two aryl reactants take place in the presence of sodium and a saturated ring is obtained which on oxidation becomes unsaturated thereby getting converted into anthracene. This is the fourth method of synthesis that is from beta benzylidene propionic acid. So benzylidene 3-propionic acid undergoes dehydration in the presence of concentrated sulfuric acid and very soon interchanges into between the ketoenol form. There is a continuous shift between ketoenol form. Keto form is the ketonic form, and enol is the alcoholic form. That is shown in the picture also. And then, with the liberation of zinc oxide in the presence of zinc, naphthalene is obtained as the final product. Now, next method in our series is Haworth method. Haworth method is a multi-step method that has been shown alongside in the white box. And the first step involves the Friedel-Crafts acylation reaction, which takes place with benzene and succinic anhydride in the presence of AlCl3 and yields 3-benzoyl propionic acid. Then next is the Clemenson's reaction with 3-benzoyl propionic acid, and it yields 4-phenyl butanoic acid in the presence of amalgamated zinc and hydrochloric acid couple. On heating the step 2 product in the presence of concentrated sulfuric acid, the resultant is the formation of ring structure of alpha tetraene by elimination of water molecule. Fourth step involves again the Clemenson's reaction of alpha tetraene giving tetrahydronaphthalene again in amalgamated zinc and HCl couple. And the last step is the dehydrogenation of tetrahydronaphthalene in the presence of selenium and at high temperature, which finally results in the formation of naphthalene. So proceeding further are the chemical properties of naphthalene, and I don't think they need any further description. All the compounds like naphthaquinone, phthalic anhydride, then tetralin, decalin, sulfonic acid compounds, and many more compounds are your purely known compounds, and you are very well aware of these compounds. So they don't need any further description. So as far as reactivity of anthracene is considered, C14H10 is not a new compound to you. That these reactivity and reactions are well known by you. As the active positions of anthracene, it has 4 alpha positions, that is 1, 4, 5 and 8. It has another 4 of beta positions, that is 2, 3, 6 and 7, and the 9 and 10 naming numbering positions are the gamma positions. The reaction involve a number of compound formation at gamma positions. However, some of the compounds have been formed at alpha positions. So that is the final compound structure and formation of anthracene and polycyclic compounds. There are certain more reactions in the presence of light also that has been shown for anthracene in the adjacent box. So this dimer, which is called dianthracene or paranthacene, is connected by a pair of the new carbon-carbon bond, which is a result of 4,4 cycloaddition. And it reverts back to the same initial compound in the presence of heat, that is thermally, or with UV radiation. So friends, that's all in this video. I hope you have found the topic interesting and also it has been a good learning experience for you. Hope to see you soon in my next video. Till then, stay safe, stay healthy. Bye bye.